Today, we're going to be covering the difference of two squares. And the difference of two squares states that a squared minus b squared is the same as a plus b times a minus b. Now, how can we illustrate this using a diagram? So let's draw a square and we'll label it having side lengths a. Okay, so I'm just going to label this right here as a bit higher. And now within that, I'm going to draw another rectangle with side length b. And because I'm taking away, I'm trying to find the area outside. So I'm trying to find this total red area. Okay? Now, how can I do that? There's two ways in which I could show this. I'm going to start off by labeling this right here as a minus b, right? And I'm going to do the same right here, a minus b. Okay? I'm going to split this L sort of shape into two parts right here. Let's first focus on this first part, which I just shaded in red. So the area of this first part is going to be a minus b, because that is the width, and the height is just b. Now let's add the second part, which is this, plus a minus b again, because that's the width, and I'm going to add times the length, which is a, times a. Now I can factor out entirely a minus b, and we get a plus b, which is exactly what I have right here. Now there's another way that I could do this. Visualize rotating this piece round right here. And we can do this because they both have the same width. So I'm going to draw on the extension in blue. So now I have one massive rectangle that I'm drawing in blue. Okay? And we know that the width of this massive rectangle is just a minus b. But what is the length? So this part is a. And because I'm just rotating this round, this part is going to be b, because this part is b. So the entire length is just a plus b. So the area is going to be a minus b times a plus b, which is the same as what we have here, which is the same as what we have here. Okay, now I can also prove this by expanding it out. So let's do that. A plus b times a minus b. So we can expand this out by doing that, and that. And we get a times a is a squared, a times minus b is minus ab, b times a is ab, and b times b is b squared. And we can see that the minus ab and the plus ab cancel each other out. So it's just a squared plus b squared. The plus ab and the minus b make minus b squared. So that just gets us a squared minus b squared. Okay. Now let's see how this concept can be useful. And it is very good for speedy subtraction. For example, if I'm trying to work out 49 minus 25. Okay, this is a bad example because you can easily work out what this is in our heads, which is 24. However, another way of doing this is we can represent 49 as 7 squared minus 25 as minus 5 squared. And this is the same as 7 minus 5 and 7 plus 5, as we showed already right here. Okay, and what is this? This is just 2 times 12, which is 24. Okay, let's go over another example. 10,001 squared minus 9,999 squared. Again, I can just rewrite this as 10,001 minus 9,999 times the sum of these two, 10,001 plus 9,999, and the subtraction is just going to be 2, and this is just going to be 20,000, and this is 40,000. And clearly this is a lot easier than doing 10,001 squared and then subtracting 9,999 squared. Okay? Now, this only works for exact squares. Okay? So, the square number here has to be 49 and has to be 25. Because then only then can we write it as 7 squared and 5 squared. Okay. Now, this is also useful because we can factorize. Let me write this here. Okay, let's factorize x to the 4 minus 16. Okay. Notice how this is a difference of two squares. Now, this may not be obvious, but what it is it's x squared to the power of 2 minus 4 to the power of 2. So here a is x squared and b is 4. Now we can write this as x squared minus 4 and x squared plus 4. Okay? But look, here again, x squared minus 4 is again a difference of two squares. So I can rewrite this as x minus 2, because square root of 4 is 2, x plus 2, and I just have to leave this the same because it's a sum of two squares, which you can't factorize, like this. So boom. This is our final answer right here. When you factorize it. Okay? Now, this is also very useful when looking at certain questions, which I'll cover right now. Let's say, and the question is, how many right-angled triangles can we create which all have integer side lengths, and the shortest side has length 11? Okay, now let's first obviously draw this out. What are we talking about here? So we have a right-angled triangle. Draw that in. And it said the question states that the shortest side length is 11. So let me just write this as 11. Okay? And the question is asking how many triangles can we have where all these side lengths are integers and 11 has to be the smallest. Okay, so we know that 11 cannot be the hypotenuse because the hypotenuse is always the longest. So let's just say it is this leg right here. Now let's also let's write this as B, and let's write this as C. Okay? From Pythagoras, we know that a squared plus b squared is equal to c squared. And in this case, that means 11 squared plus b squared is equal to c squared. Okay, now you must be like, where's the difference of two squares here? I'm coming on to that. 11 squared is the same as c squared minus b squared. Okay, now we have a difference of two squares. So I can rewrite this as 11 squared is the same as c minus b and c plus b. Okay, so, and 11 squared, 11 is prime, right? That means 11 squared will only have three factors. 1, 11, and 11 squared. And let me show you what I mean. This 11 squared is 121. So, a number times another number gets us 121. Okay, so basically we are looking for each of these is a factor of 121. So what are all the factors of 121? We have 1, we have 11, and we have 121. Okay, now c minus b is obviously smaller than a plus b. So c minus b could be 1, c plus b could be 121. Or C minus B could be 11, and C plus B could also be 11. Okay? However, if C minus B and C plus B are both 11, then B has to be 0, and B can't be 0 because it's the side length. And also, B has to be greater than 11. So that's out. So C minus B has to be 1, and C plus B has to be 121. Now, you just got simultaneous equations. I can add both these equations up. The b's cancel out. So 2c is equal to 122. So c is equal to 61. And that means b is equal to 50. And this is the only possibility. Oops. Therefore, there's only one triangle possible. And that triangle is a 11, 50, 61 triangle. Okay. Now, we can also use number theory. Okay, and say I want to represent a certain number as, let me just pull this down here. Say I want to represent, say, 437 as a difference of two squares. Now, if the number is odd, we can always represent it as a difference of two squares. But why? Okay, let's delve into this. So let's say 437 has to be a squared minus b squared. That's what we want. And we want a and b. Now this is the same as a plus b and a minus b, as we've already established. So let's think of two factors of 437. And we're always going to default to 1 and the number. So a minus b is going to be 1. And a plus b is going to be 437. But you must be wondering, why does the number have to be odd? Now, let me explain why. So a plus b is going to be 437. And a minus b is going to be 1. If I add them up, plus b minus b cancel out. So 2a is equal to 437 plus 1, which is 2a is equal to 438. Now, two a is 438. So 2a, we know that 2a is going to be even, right? And in order for 437 plus 1 to also be even, we need 437 to always be odd. Okay? And so in this case, a is just going to be 438 over 2, which is 219. Okay? Now, to generalize, let me just replace this with, write it in red or blue. Let's write this as n. Okay? And so a minus b is going to be 1, and now a plus b is going to be n. Okay? So a plus b is n, and this is 1. So I'm going to sum it up. So 2a has to be a n plus 1. Now, in order for n plus 1 to be even, we need n to be odd. And in this case, it is. Okay? So a is going to be 219, and b is going to be 218. Okay. Now, if you want a fun question to solve, try and solve this. Find all right angle triangles with the shortest side being 29. Okay? And please feel free to post the answer in the comments. Okay. Thank you very much for watching this video. Here are the common topics that you'll need to understand this video. You'll have to have a strong understanding of the Pythagoras' theorem, as it's helpful when answering this kind of question. You'll have to understand factorization. You'll have to understand how to expand out brackets like we did at the very start. And you'll also have to understand solving simultaneous equations, which I will create another video on, which will be my next video. Okay? Thank you very much for watching. Please don't forget to like and subscribe. Bye.